This is Engineer Nasir from NC Engineering and Technology. Welcome to our series Primary, Secondary, Tertiary Chillwater Pumping System. In HVAC chillwater distribution system, there are commonly used four types of pumping system, and they are as number 1 constant volume primary chillwater system, number 2 variable flow primary secondary system, number 3 variable flow primary secondary and tertiary chillwater system, and number 4 is the variable flow primary chillwater system. As we already discussed the number 1 constant volume primary chillwater system in part 1, now in part 2 we will discuss the variable flow primary secondary chillwater system. First we will start to understand the definitions used in this topic. Then we will understand the subject with the help of schematic diagram, and in the end we will have sample calculations. Now we'll study the primary and secondary chillwater system. As we know, long time ago primary constant chillwater pump was used, and by this method a lot of power was wasted. In mid-90s, VFD technology became more affordable and its control more accessible. Then the primary secondary chillwater system was born. In this system, the secondary or the building side was supplied with variable speed pumps, while the chiller plant remained primary flow as its equipment was not built for varying speed. In this system, we split the whole system into two parts. A primary secondary pumping system divides the total chillwater network into two distinct loops that are hydraulically separated by a neutral bridge called decoupler. Or in simple words, in primary secondary chillwater piping system, the total chillwater piping network is divided into two parts. One we name primary loop and the second we name secondary loop. Both these loops are interconnected by a bypass line. We call it decoupler line. Now we'll study in detail what is primary and secondary loop and how they work. Also we will study what is decoupler line, how it works, and how to size it. What is primary loop? A primary loop is the place where the chill water is produced, and its main components are chiller and pumps. The primary pumps are typically constant volume and low head pumps intended to provide a constant flow through the evaporator of the chiller. What is secondary loop? The secondary loop is the chill water piping network outside the chiller plant and inside the building connecting the air terminals, and it is responsible to receive the chill water from the chiller plant and to distribute it inside the building up to the terminal units such as HUs, FCUs and control valve. The secondary pump are variable speed and are sized to move the flow rate and head intended to overcome the pressure drop of secondary loop only. What is neutral bridge or decoupler pipe? The neutral bridge consists of two T's that are typically located at the suction header of the secondary pumps and at the suction header of the primary pumps and are connected by a decoupling pipe. This decoupler separates the primary and secondary loop. I draw for you an schematic for primary and secondary chillwater piping network to make more easy and clear to understand how the primary and secondary loop work. We have divided by dotted lines this network into two parts. One is primary loop and the second is the secondary loop. As you can see, in the primary loop there are two major components. One is the chiller and second is the pump. As we also know, a conventional chiller is designed based on two fixed parameters. Number 1, a constant flow of chill water through it. Number 2, a fixed set point temperature at its outlet. So to provide a constant flow of chill water through it, we need to use constant speed chill water pump having a low head only to cover the chill water flow through the chiller. This pump arrangement can be any of two types, tandem or headed, and this pump arrangement we will study in separate video in details. In secondary loop, we have air terminal devices, HUs and FCUs that are fixed with a two-way valve and variable speed secondary pump that are controlled by variable frequency drive that got signal from differential pressure sensor that is installed at the end of chill water network between supply and return piping. In this schematic diagram, this is the decoupler pipe and it is connected between the suction header of the secondary pump and the suction header of the primary pump, and this common pipe separates the primary loop and the secondary loop. This common pipe is designed for negligible pressure drop at design flow. A well-designed low pressure drop common pipe is the heart of primary and secondary pumping, allowing the two pumps to operate independently. A well-designed bypass line or decoupler line will allow the secondary pump to work independently of the primary pump. If there is less demand of the chill water in the secondary circuit or secondary loop, the bypass line will allow the extra chill water to pass through it and again to the primary loop. In this way, it is the heart of the primary secondary chill water pumping system. How to design the decoupler or bypass line? In a primary secondary chill water piping network, the diameter of the decoupler or bypass line is same as the chill water piping diameter going to the largest chiller, and its length is 8 to 10 times the diameter. It is normal practice during designing the diameter of the decoupler line to add 10 to 15% of extra flow to the flow of largest chiller. The function of decoupler or bypass line you can understand when we will make the study of operation of the total chill water piping network. To understand the behavior of primary and secondary chill water system during operation, first we will make the study at full load condition, then we will proceed to make a detailed study at part load condition. At full load condition, the two-way valve will be fully open and will allow the total design chill water to flow through the HU, and the HU will work at full capacity. And as the differential pressure between the supply and return will be zero, the variable speed pump will operate at full load, full capacity, and will supply a total 1200 GPM chill water flow inside the secondary loop. And as the primary loop is designed for a constant flow of 1200 GPM, so there will be a constant flow of 1200 GPM throughout the total chill water piping network. In this case, the decoupler line or bypass line will be ideal, as the chill water flow in the return line coming from the secondary loop is equal to the chill water flow in the return line inside the primary loop. So no need to bypass any chill water from the supply side. To understand the operation of primary and secondary chill water piping system at part load condition, we will study it in different cases. We will consider different cases of HU working at different capacity. Let us start now case 1, assuming all HU working at 70% capacity. For case 1, we have assumed all HU working at 70% of their full capacity. As we have selected the HUs at 200 GPM to work for full capacity, so the GPM needed at 70% capacity will be 140 GPM, and the two-way valve will allow only 140 GPM to pass through the HU. Because of this, there will be a differential pressure between the supply and return piping, and this differential pressure will be sensed by the differential pressure sensor there, and it will send the signal to the variable frequency drive to slow down the variable speed chill water pump. If we multiply 6 HU into 140, we will get a total GPM of 840. So there will be a total chill water flow in the secondary loop of 840 GPM, and the secondary pump will adjust their speed according to the required load. When we go to the primary loop, we find that there are 3 chill water pumps working at constant speed producing 400 GPM each. So the total GPM in the primary loop is 1200 GPM, and the primary loop need to flow continuously a constant flow of 1200 GPM. So in this case we found there is difference in the chill water flow in primary and secondary loop. In primary loop we have 1200 GPM, whereas in the secondary loop we have only 840 GPM. There is a difference of 260 GPM. For air conditioning system to work, we must follow the chill water from the chiller plant up to the air terminal units. So how to balance it? In this case we will use the decoupler line. So the balance 260 GPM will bypass through the decoupler line, and 840 GPM will pass from the secondary loop. So 840 plus 260 will be 1200 GPM. So there will be a total flow from the secondary loop to the primary loop 1200. That is same as the chill water flow of primary loop. For case 2, we have assumed that all HUs are working at 60% of their full capacity. As we have selected the HU of 200 GPM for total capacity, so the GPM needed for 60% capacity will be 120 GPM, and the two-way valve will allow only to flow through the HU 120 GPM. Due to this, there will be a differential pressure between the supply and the return at the end, and this differential pressure will be sensed by the differential pressure sensor, and it will send the signal to the variable frequency drive that will slow down the speed of the chill water pump to balance the flow as per the space requirement. So now the chill water flow in the secondary loop will be only 720 GPM, and the secondary pump will adjust their speed accordingly. Now we'll go to the primary loop. Here we have 3 chill water pump working at constant speed having a GPM of 400. So the total GPM in the primary loop will be 1200 GPM, and to keep the chiller working we must run a constant flow through them. So in this case there will be different chill water flow in the primary loop and secondary loop. In the primary loop we have 1200 GPM, whereas in the secondary loop we will have only 720 GPM. There will be a difference of 480 GPM. To make this difference, the decoupler line will allow to pass a quantity of 480 GPM through it, so that in the secondary loop we have a constant flow of 1200 GPM. When the chill water flow through the decoupler line reaches the capacity of a chill water pump in the primary loop, then one chill water pump is turned off. But before turning off the largest chiller, we wait until the chill water flow through the decoupler line reaches 10 to 15% more than the capacity of the largest chiller. When the chill water flow through the decoupler line becomes 10 to 15% more than the capacity of the largest chiller, then one chiller also is turned off. In this case, there will be only 2 chill water pump and 2 chiller are working in the primary loop, and there will be a total flow of 800 GPM. And as the flow in the secondary loop is 720 GPM, so still there is difference of 80 GPM, and this difference will be bypassed through the decoupler line to maintain the constant flow in the primary loop. Now we can summarize our study as: at the start of HVAC system, the primary secondary chill water piping system will work at full load condition, and both the loop primary and secondary loop will work at full load capacity. When this difference between chill water flow in primary and secondary loop is less than the capacity of a chill water pump in the primary loop, we compensate this difference by chill water flow through the decoupler line. But as this difference became equal to or greater than the capacity of a chill water pump in the primary loop, then we turned off one chill water pump and one chiller to maintain a constant chill water flow in the primary loop that is equal to or greater than the chill water flow in the secondary loop. So after continuous operation of air conditioning system, the space cooling load decreases, and due to this decreasing cooling load, variable frequency drive control the variable speed chill water pump and slow down. In the same way, if this load is decreasing more, we can turn off one chill water pump and one chiller in the primary loop also. In this way, this primary secondary chill water pumping system help us to save the energy.